Hi everyone. So today I want to talk about section 6.4, chapter 6, math 110. In this chapter, we're gonna solving for time in the inches problems. For example, if you deposit some money and then um, you want to earn some amount of money and then you want to find like how many years you need to get to up to that amount of money. So that is today what we are doing. Okay, let's go ahead and work on example number one here. We have $1,000 and earning is 8% interest. Okay, so I know that this should be P. Uh, so P going to be equal to 1,000. The initial amount will be $1,000, and then the rate will be 0.08. And this is compound continuously, so then you have to use AT equal to P times E for RT. Okay, so then you're gonna apply all this information into the formula here to get this function. Okay, so that is the reason why we have AT equal to 1,000 times E to the power 0.08. So how long does it take for your account to grow to 15,000? So this means like amount you want in the future, right? So the I call it future amount is mean 80 now equal to 15,000. Okay, and then now we're looking for how long. We mean a year, right? How many years you need to get to the up to that. So now I'm gonna apply this future amount into this equation to get 1,500 equal to 1,000 times e to the power 0.08 t. So that is our strategy, and then we want to solve for this, right? And that to solve this, we actually learn from log and exponential to solving this function. It is exponential function, so to solve it, you need to use log. But anyway, that's just for idea to find the time, right? And then another question is I'm gonna say is like A and here's B, right? Another problem say how long does it take for your account to double in value? So double in value mean the amount future now will be double from the initial amount, which mean 2 times P, and which mean 2 times 1,000, and that's equal to 2,000, right? So now you are having 80 equal to 2,000, and then you just gonna substitute this future amount into the formula 80 equal to 1,000 times e to the power 0.08 t, right? And then you're gonna have solve the equation as 2,000 equal to 1,000 times e to the power 0.08 t. Okay, so that is the equation that we need to solve for t in order to know how long to get to that amount. Okay, let's move down here and see if we can using graphical method to estimate or to approximate the answer. So here is a graph of the equation of the first equation for part A in the example above, which is 15,000 equal to 1,000 times e to power 0.08 t. So in order to see the solution for t in here, you actually look at the line 15,000, y equal 15,000. So that's going to be a horizontal line that goes through the point, go to the value, the y value 15,000 over here. So that is this line. Okay, and this line is intersect with the function. This is the function of 1,000 e to power 0.08 t. Okay, and this function I'm gonna write as y equals to this. This function intersect with y equal to 15,000 and is intersect each other at the solution for this equation for this equation. Okay, so so then I will estimate this will be I think it's still about like 33 years something. Okay, just say 34 years. So approximate is about 34 years. Okay, that's what we approximate the answer. So, but this graphical method will not be will not be very accurate if we do like this, right? So in order to make it become like very accurate, and usually if you take a test, you don't want to just do this. It's just for you to approximate. You don't, it's gonna be like no clue is that the true answer, right? So you have to solve by using logarithm properties and exponential properties to handle this problem. Okay, so let's move down and solve this and see about this. Okay, so okay, this is another one. Let's see. It's a present value of 1,000 is invest at 10% compounded continuously, and how many years are required for a future value of 3,000, and use the graph to find an approximate solution to the equation for the number of years t and so then in here we know that future amount is 3,000, and initial amount is 1,000. So then the formula or the equation had to be 3,000 equal to 1,000 times e to power 0.10 t, because the rate in here is 10%, so 0.1. Okay, so now under here is a graph of y equal to 1,000 e to power 0.1 t. And in order to estimate the t, you just find the y value equal to 3,000 here, and then try to have the coordinate, I mean the point that on the graph for that value, and then coordinate for the x value in here, or the t value in here. The t value here is exactly 11. So I would say that is 11 years. And again, to get more accurate value, the time, we need to use logarithm. Okay, so so let's see if the next page we're gonna start to work on that, right? All right, so here is exponents and logarithm. Some rules and properties that you may have to consider about that. So first thing is about log in base 10. The log of positive number y is the exponent x in the equation 10 to the power x equal y. Okay. And now, in order to have some idea for solve this equation, right? Or change it to be log form. We're gonna have some like we're gonna have a table here that have some case for x and y. So in the left hand side here, I have exponent form, and the right hand side is the equivalent logarithmic form. So from the left hand side, I can convert to the right hand side, or in another way, from the right hand side, I can convert to the left hand side. So take a look at the first one. You see that y is argument here, right? Is y is the argument. So you can have like a log base 10 of y gonna be equal to x, something like that, right? So so that's the reason why I have here log base 10 equal log base 10 of y equal x. So remember that if I don't have any number at the base here, it's mean number 10. There's hidden 10 as a base. Okay, so that is a thing you need to know. And now we have the second one, the second row, say 100 equal to 10 to the power 2. Okay, so if you want to convert it to be log form, it's gonna be a log base 10 of 100 equal to 2. So log base 10 of 100 equal to 2, right? See that? So if you take a note, you can see that the argument is always be the term that doesn't have exponent. And the base is actually the base of the exponent. So okay, so now let's try to do the third one. So I'm gonna write log. Okay, log base what? Base 10. Okay, I don't need to write base 10 because log is mean base 10 already. Okay. And of what? Of the argument over here. Okay. Log by 10 of 1000. So 1000 equal to the exponent. Okay. Equal to exponent. Right? See that? So that is a way to convert it from the exponent to the log form. Okay. Similarly, for the fourth here, I'm gonna have logs base 10, right, of 199.526 will be equal to the exponent 2.3. Okay, remember that log, all the log is mean the exponent. Okay, the whole log is mean the exponent. So that's the reason why exponent always stay in one side of the log, in another side of the log, right? Okay, so now conversely, I want to convert from log form to exponent form. So so you actually have to remember that base in here is 10 to power exponent here. So I have like 10. Maybe I'm gonna have I'm gonna try to have like a smaller. Okay, here 1 second. Try to have a smaller pen. All right, so maybe better now. So I have 10 to power 1.60206 equal to the argument 40. Okay, so that gonna be the way, right? Okay, so last one. I have log base 10 over here of 0.056234 equal to the power negative 1.25. That's gonna be it. Okay, so now come to an exponential equation. I want to solve for x for 10x equal to 199.526. I will just change it to be log form. I will have log base 10, okay, base 10 of 199.526 gonna be equal to x. See that? So now you actually have x already. X actually be in one side already, and what you do right now is use a calculator and tell me what is log 199.526 gonna be equal to. So let's try to use calculator now. Okay, so here is my calculator, and let me clean this up. I will use log by 10. So here's log by 10 over here. See that? Log, and then 199.526. Close the parentheses, enter. Okay, so now that's going to be answer for x. And actually, you're going to say x equal to, what is that going to be? 2.29. So I'm going to say 2.3. So 2.3, yeah, something. I just round to one decimal only. Okay, so now that is a way to use calculator for solving exponential equation. So let's move down to see if they have something else. Okay. So here is using log to solve equation. Okay, still doing it. Logarithm are used to solve equation where the unknown is the exponent. Okay, easily. So if you see the unknown is the exponent, you're gonna use log easily. Okay, so now it just try to ask you to solve 10x equal to 40. You're actually gonna convert this to be x equal to log base 10 of 40. See that? And then log base 10 of 40, use the calculator going to be equal to 1.602. You can use the calculator to check it. All right. In general, the solution x to 10x equal y is called the common log of y. Okay. And is written x equal to log of y. For many values of y, log y is quite hard to compute without a calculator. Okay, that's why your calculator has a log button. Use a calculator to solve this equation for x. Okay, now let's try for this one. All right. So firstly, you change this to be the log form, right? So I have log. What is the base in this exponent? I know it's 10, right? So base 10, I don't need to put the number 10. Of what? Of the argument 45 here. Okay, now equal to what? The exponent x. Okay, see, easy. You're gonna have x equal to, use a calculator, and you're gonna have log 45 equal to 1.65. So that's just right, 1.65. 1.65. I don't want to have too many number. Okay, so now for this, for the next one, easily log base 10. Okay, base 10. So of what? 1.365, right? Equal to what? Equal to x, the exponent. Okay, so now you're gonna use a calculator and just solve it. Just tell me what is that gonna be. I don't want to do it, so I'm gonna skip it and move to the next one. All right. Wow, this problem could be a little bit tough for you if you right away try to convert to be the log form. Actually, you cannot convert it to the log form right away. You have to isolate the exponent, the exponential form alone. So it means what? It means I don't want to have a number 4 next to 10x anymore. I want to eliminate it. Okay, so how can I do that? I will divide both inside by 4 because 4 is multiplying with 10x. So what do I have right now? 10 to power x equal to 15.66 divided by 4. I can just keep it like this. I don't really care to see what is that going to be. Now it's time to use log form. Okay, so you can use log by 10. Okay. Before move to this step, I just want to clarify that when you isolate the exponent form already, or the exponential term already, you can apply log form. You can convert it to be log form at this point. Okay. Otherwise, you should eliminate all the crazy stuff next to it. All right. So now logs by 10 of what? Of the argument over here. So I'm gonna put all that 15.66 over 4 equal to what? The exponent is x, easily, right? Okay. So So now now you can just use a calculator and find what is this gonna be, and I'm gonna try to do it for you. Okay. If you have TI-83, it's gonna be P of x for you at this point. It's gonna be log 15.66 divided by 4 and close it, right? Enter, and that's gonna be it. If you don't have TI-83, if you have some scientific calculator, you have to do the 15.66 divided by 4 first, right? And then you're gonna do log base 10 of this number, and that should have the same answer as 0.59. So x equal to 0.59, and I usually like to circle the answer. So something. All right. Okay, so let's move down. So now we're going to talk about logarithm in base E, the Euler number, and you still remember that the future value formula for continuous compounding is A equal to, let's just cross this because this is wrong, and I'm going to write as A equal to P times e to power RT, right? Okay. And if you are given the value of A, P, and R, you will need the log with base E to solve this equation above. The log with base E is written as ln, okay? And the solution of x, the solution x to the equation ex is y, is called natural log of y, and is written as x is equal to ln y. Okay, so let's move down and see what we have. Okay, here is exponent form. The left hand side is exponent form, and the right hand side is log form. And you can see is similar with the table above about the base 10. You can just change from the exponential form to be the log form, and conversely, you can convert from the log form to the exponent form. Okay. So now let's try to use calculation above to solve the equation. So Ex equals 6. Easily you can convert it to be log form. It is log base E, right? Base here is E, which is L of n, or natural log, equal to of 6. Equal to the exponent, which is x. Okay, so now you can use calculator to tell me what is x. But actually, ln 6 in here, the given us is 1.79176 already. So I'm gonna just say 1.79176, right? So that's gonna be the answer. You can also use a calculator to do that, but I will show you later for the other problem, not this one. Okay, so next, the next problem having, I believe that this problem is typo. Is want you to do as 2 to power 2 times e to power x equal to 3.4. That's what they want. Okay, so firstly, you need to eliminate number 2 because it's next to the exponential term. Okay, so I will divide by 2 both hand side. And I have e to the x equal to 3.4 divided by 2. So I have 3.4 divided by 2. So I have 1.7. 1.7. Okay, so now you will just gonna convert it to the log form. So log base e, so which means natural log of 1.7 equal to the exponent, which is x. Okay, now use the calculator to find ln of 1.7. So remember that ln is here, right? ln 1.7 equal to 0.5306. It's actually here for you to see. So I will easily know that x equal to 0.53. Just gonna stop at the 2 decimal. Okay. So that be it. For the next problem, I am having e to the power 0.10t. Okay, now let's see what I'm gonna do for this problem. I'm gonna convert it to be the log form. So natural log, so of 3 equal to the exponent with its power. What is that? Remember that it is all of this, right? So 0.1 t, 0.10t, which means 0.1 t, right? So now you are looking for t, so you need to divide by 0.1 both hand side. Okay, now you have t will be equal to ln 3 divided by 0.1. What is ln of 3? Is this guy. Okay, so I will have 0. No, sorry. It is 1. What happened with my 1.09? Nah, that's right, to be 3 decimal place, and then divide by 0.1. And now I have I'm gonna use my use calculator to do this. But for this one actually it's easy. You can just move the decimal from the of the numerator to the right hand side 1 unit. So 10.99. Okay, so that's going to be the answer for T. 10.99. All right, so the next problem is, I will actually let you guys do it. Okay, so okay, so let's see for this problem. For the next one. Okay. So on this page, it talks about 2 properties of the natural log that you know, that you need to know. The first one we call fact number 1 is ln of e to the power x will be equal to x. So that's clearly that's the ln is log by e is we'll cancel the base e inside the argument and left with the x only. So this one of the properties that you really need to remember. And another one is if you have ln of a to power x, then you're just gonna move out the power x here in the front of ln so because of the ln in here, you actually can move out the x from the power to be like a normal I mean like a base number. So so that is fact 2, or the second property in the natural log. And down here the table is application that you can use for fact number 1 and fact number 2. So you can see, for example, in this one, you have ln of e to power 0.03t. It's just going to be the power. It's just going to be equal to 0.03t, right? And similarly, 0.09t going to be here, right? So remember that's because the base e here can be eliminated by the base, the hidden base is e in here. So so then the answer, the ln in here, the log, natural log in here, just equal to the power of e in here. Okay. For the fact number 2, what we do is we just gonna move down the 40 in front of the ln, because the base in here is not the e, is not the number e. So so then you have to move down 40 in front of it, and then use a calculator to find the ln of 1.02, which equal to 0.0198. And now you can solve, I mean, you can use this as a step for you to solve a problem with the exponential formula. So similarly, with the as problem, you can just put down the 2t in front of the log. I mean the power in the inside of the argument, just put that in front of the log, and then simplify the log by the calculator. So that is a way to apply for the 2 properties in the natural log. Okay, let's move to the next page. Okay, so let's use fact 1 to solve the future present value formula for t. Okay, now we come back with the problem before, right? Is use log to solve the equation for the number of year t. Okay, so now you need to know that for 3,000 equal to 1,000 here, firstly you need to divide by 1,000 both hand side, because you don't want to have this 1,000 bugging you in the right hand side. So you divide by 1,000 both hand side, and you will get to this step, e to power 1.10t equal to 3. Okay, now is isolate the exponential term already, and now you can just do ln both hand side. You're just gonna do a natural log both hand side for this step, and then apply for the fact 1, or the first property of the natural log. You will have just the power 0.1t going to be equal to ln of 3. Okay, so so then t will be equal to ln 3 over 0.1, and that's going to equal to 10.986 12. Okay, so that is idea to use fact 1. Okay, so this I'm gonna call step is take natural log both hand side. Okay, both hand side. Okay, So then the answer should be, it takes 10.9861 years for a present value of $1,000 to grow to the future value of 3,000 at the rate of 10% compound continuously. Okay. Now, we're going to use a graph to solve the equation for the number of year t. Okay. I'm going to say approximate with the graphical method. So look for the 5,000 for the future value is here, right? So then coordinate it to get the point on the graph. I'm going to use the other color. Let's use red one. Okay, it's here. And the equivalent value for that point, we have t is at 18. So t is around 18 years, I think. Okay, so that is my approximate by using graph. Okay, so let's move to the next one. Now, we're gonna use log to solve the equation for a number of GT. Okay, so firstly, I don't want to get 1,200 here. I don't want to have that number. I'm gonna divide by 1,200. Why I don't want it? Because it's multiplied by the exponential term e to the power something. So I want to isolate it. So I need to divide both inside by 1,200. So now the left hand side will be 5/12, and the right hand, no, 50/12. Oh, actually, I'm going to use calculator for this. So let me open my calculator. Okay, so here's my calculator. I will have 5,000. I divide by 1,200 and then enter. Oh, it's not a good number. So I would love to change it to be rational. How can I make it? Okay. So let's delete this one. Okay. So I want to convert this to a fraction. So use math here. And number one, I have 25/6. So put 25/6 here and equal to e to the power 0.08 t. All right. So now you isolate the exponential term alone already. So now you can do by two methods. One is you can convert it to be log form, or the second way is you can using ln both hand side. So I'm gonna apply the first property, the fact one, by ln both hand side, ln 25/6 equal to ln of e to the power 0.08 t. And now you will get left hand side gonna be equal to, so take ln 25 divided by 6. So that's gonna be equal to something. Okay. I just gonna keep it as ln 25/6. And then the right hand side will be, now the ln e will actually be cancelled, and you have 0.08 t only. So that's gonna be for the right hand side. Now you just need to divide by 0.08 both hand side. 0.08 both hand side. So then you will get t equal to this guy, right? So let's use a calculator for this time. So we have ln of 25 divided by 6 going to be 1.427 somethings over here. You want to divide it by 0.08. And then you have 17.84. Okay, so I'm going to have 17.84 years. Okay, that is for this equation. What about this problem? Okay, I have to divide by 1000 both inside. So now I have left hand side gonna be 36 divided by 10 gonna be 18/5. And then that will be equal to e to the power 0.05 t. And now you can take ln both hand side. Equal to ln of e to the power 0.05 t. You can actually, I mean, if you remember the way I do before, you can actually right away convert it to be the exponent form. It should be the same. So, for example, if I use the exponent convert to exponential form, I'm gonna make it like, okay, the log base e, right? So which is ln of this guy, so 18.5 will be equal to 0.05 t, right? Will be equal to exponent. So it's look like actually it's gonna be look like quicker than the way using the first property, because the first property will come to ln both hand side first and then come to this way, right? Come to this step. I mean, either way, if you feel not remember, you cannot remember the way from changing the way that changing from exponential form to the log form, you can use ln both hand side. That could be okay too. So so now you will have divide both hand side by 0.05. And answer gonna be t equal to use a calculator. So ln 18 divided by 5, close the parentheses, and then divided by 0.05. And that's going to be 25.62. 25.62 years. Okay, that's going to be it. And we're done with section 6.4. If you have any question, you can come to my live lecture. I mean, my live Zoom lecture, and we'll see you on the next section. Bye.